Welcome to Full Send Engineering. This is episode number 3. And today we've got a very, very special guest, David Oliveira. Dave, welcome to the show.
Thank you. It's a pleasure to be here. Thank you.
Now, David and I first met probably around 15 years ago down at University of Wollongong. At the time, Dave was leading some of the most challenging subjects and teaching some of the hardest things that we were struggling with back in the day. And you were studying your PhD down there in geomechanics and geotechnics. Dave, ever since I met you, you've really had this knack of connecting the theory with the practical. So whether that's through your research or through your industry connections, you've always had a way of really bridging that gap between the theory and the practice. And that's what we're hoping to dive into today. I'm very excited to have you on the show. So, yeah, welcome, mate.
Thank you very much. As I said, I'm very excited. Yes, and whatever the stories I can share and share a bit of my passion and enthusiasm will be great.
Yeah. So we might start back at the university days. I kind of wanted to touch on what ignited the spark for you in geotechnics, because that's kind of what I knew about, but I know you ventured on from there. What really ignited that spark for you in what is really a challenging and quite a difficult area to study?
Yes, it's an interesting story, actually. So, as you know, I'm originally from Brazil, and that's where I did my undergrad studies in civil engineering. And at the time, I had to work as an intern to support myself financially, and through that need, I had to change jobs. And the interesting thing is that at that time in particular, I had done probably only one subject in the area of geotechnics or ground engineering, as I prefer to call, and I really hated it. I really didn't like it. I thought it was, it didn't really spark anything. It was missing something. It was boring. But in that search for a job or for internship to support financially myself, there was this advertisement saying we need someone to help us with some earth dams engineering, and I said, Jesus, I don't like this subject, but I really need to work. I'll give it a go. And then I learned that it's all about the people who you work with and the people who teach you. And I found a fantastic group of mentors there, particularly 2 in that company, who really sparked my interest and made me see the subject differently. So from then, then it completely changed my view. Still in my undergrad study, I started focusing more on subjects that were particularly specific for geotechnics. So from then, I did even electives that were, not only sort of the geotechnics or geomechanics 2, soil mechanics 2. I did advanced foundation engineering. I did earth dams. I did rock mechanics in an undergrad study, and it really sparked. So it's unfortunately sometimes it's not. You may have fantastic lecturers who really know the subject, but sometimes they are unable to get that inspiration out of students. It's and that's what was missing, and I found that person. So if it is an advice that I can really give to anyone who's starting their career or is starting their studies, it's try to really find the right people. If you're starting your job, try to find the right mentors. You're starting an internship, look for that people that you think can give you that inspiration.
You've kind of taken me back to my UOW days where we're doing geomechanics too. And we're all the crew that we were studying at the time. We're all just like, what is going on here? Like, this is actually next level. But there was something about it that really sparked our interest too. And so you're talking about finding a mentor and talking about finding someone. What is it that person did for you in those days? Because it's not something that you can just go and say, that person's smart, I'm going to go and align with them. Although that's sometimes a good thing to do also. But what was that person doing for you in those times?
So, and that's where, your first question, your first mention, trying to link theory to practice. That's exactly that this mentor of mine, and he was actually pretty young too. He was probably only maybe no more than 5 years older than me. He had just finished a master, so he was also very excited and enthusiastic in itself. And he showed me how to connect theory with practical use while doing my internship. So one of the things I love about the subject of ground engineering is that there's a high level of uncertainty. There's no way, in ground engineering, you can test every single little, square meter of soil, right? So you're always dealing with a high risk, a high level of uncertainty. So you need to use your theory in a way that you address that risk and that uncertainty. So I remember specifically in my internship, we went to visit this development, and this development was a series of buildings, and those buildings had to be evacuated because they started to settle too much and crack. And I thought, oh, Jesus, this is a big problem. It was, it's a problem. It's an exciting problem to get involved with, and he started showing me the theory behind, consolidation of soft soils and clays, and, how we can connect the theory of that consolidation and changes in groundwater levels that make it, and that was one of the sparking moments that led me to really like it.
I think sometimes when you're at uni, you struggle to really connect the dots with what you're actually doing. And when you first start working in the real world, you kind of get out into the thing, and you see, when you're actually looking at a physical problem, I think it really sparks something for young people,
It does, and that's actually one of the beauties of being an engineer is actually the chance that you have to actually work on, say, the theory behind the mathematics, the modeling, the calculations, get involved doing construction and see it built. So I think there's nothing more fulfilling than you're getting involved in a project, and then if you are able to even and are lucky to be involved through construction phase towards the end and see it being finished and and being in use, is something fantastic. Walking by the city. And I'm lucky here. I've been in Australia now 20 years, and I can walk around here in Sydney and see a few buildings that I helped to do foundation, excavation, tunnels that I have designed and helped build, and that's what I think we have to keep in mind as our end goal, and remember that at the end, that's what you're gonna see is your contribution to society, and how it can make people's life better by giving a good building for people to live in, a good foundation for structures, a good bridge, a good tunnel.
When you say that, I giggle, and the reason why I'm giggling is because when I walk around with my partner, I'm often saying, oh, that's a stormwater drain, or talking about things, and I'm like, I designed that, or I worked on that.
I understand, sometimes it might be boring, but I think we need to insist. I think we need to get people to know what we do. And, sometimes when you explain, not every time, maybe if you do that too much, I can understand maybe exhausting, but getting people to realize the challenges we face, how we address them, and the final outcome can be mind-blowing. We are very good to talk to each other as engineers. We go to an event, a conference, and something. We're all engineers, and we pat on each other's back. Oh, how great was that project? Was fantastic. You worked on, but actually to get outsiders, like people, to understand how we are able to develop things from nothing, from concepts, just do investigation and build an idea, and develop that idea into a mathematical model that it can make predictions how things will behave in the future, how it will behave. I find it amazing that we build models that, for example, for bridge, that, you put traffic, dynamic traffic, and you can see how it vibrates. You can build a model of a building, its foundation. You throw in the model wind onto it and see how it sways, like you put an earthquake. And we make predictions how these things will behave and how they will work. And in a number of cases, we can even monitor and see if our predictions are correct. And then, I get really excited when I make predictions, modeling predictions that I can monitor and measure. And then it comes back and says, Jesus, I was so close.
Spot
I
on.
was really good at it, and it gives that real sense of, increase our confidence. So we're doing a good job, right?
Yeah.
But we need to get others to know, to see what we do.
Sometimes the real hard work that we do is actually quite hidden from the world, and only the people that are closest to you in your team would actually know what was happening, at a final level.
Yeah.
Amazing. So I kind of wanted to also ask you about how you ended up coming across from Brazil to Australia. I know there's probably, millions of engineers that would love the opportunity to come and work in Australia, especially doing a PhD. How did that kind of evolve for you?
Yeah, look, it's an interesting story, and it's a combination of a couple of things. I've always tried to connect, as you mentioned, academia with practice. So I've always had a bit of a research component associated with my career. So I did master and I did a PhD. So I came here because in Brazil, when I did my master's, my group of supervisors said, "Oh, David, you really have this good understanding of research. I would like you to do a PhD." And I said, but you know what? I would like to do it abroad, like to live overseas, do a PhD overseas, because I had not had the experience of living in another country other than Brazil. And they said, so if I am to do a PhD, I'll prefer to do overseas. And they said, okay, all right. If the opportunity comes, then we know you're good and we're going to recommend you. And that's what happened, actually. A professor here from Australia went there and he said, look, I want to diversify my group of students with people from other cultures and other countries, other experiences. Would you recommend someone? And this group of professors said, we have the perfect student for you. So, of course, it was through... I reached that point through my effort of, everything I do with enthusiasm, and I put the effort of doing a good job, and that led to people liking my work and recommending, and then I came across. So there's a combination of that, my own effort, and a bit of luck, right?
Yeah.
That I had a professor that went to visit, and had the opportunity. So that was, but scholarships and opportunities, they do open up from time to time. So if you get that connection with your lecturers and professors and researchers, you can always say, look, I'm really interested, and you put your hand up and apply for it. So you get the chance to come on a scholarship, and that's how I came. I came on a local scholarship, loved the country, and decided to stay. And 20 years later, I'm here. So.
It's a pretty solid effort.
Yes.
And then I'm kind of just wondering, when you came over here, were there any things that didn't work out? When you first started doing your studies and you started diving into this really super critical theory. I think you were doing soft ground consolidation at the time, was it not?
No, actually, that's one. I wouldn't say it didn't work, but I came to do soft ground research on soft soils and consolidation. And then in the middle, not in the middle, right at the beginning, my supervisor said, you know what? I think we need to change the topic. I can't remember exactly, if it was something sparked in him, and probably he saw me and said, look, maybe I think David, you look like something that needs something a bit more solid. You're going to do studying rocks,
rock
right?
mechanics.
So I did rock mechanics,
gosh.
and then it changed. So I changed to rock mechanics and started studying more the behavior of rocks and rock formations and how they interact when we, how they behave when we're doing underground excavations and deep excavation, changes in stresses and, the interaction with the joints, the fractures that exist. So I wouldn't say, it wasn't something that didn't go wrong. It was just it changed, and I had to adapt. So I think that's the important thing, is to be able to adapt and be flexible. And I think to me it really worked. I was lucky again. There's always a little bit of, I think, like if you are at the right place at the right time, lucky, luck happens.
Yeah.
So
yeah, absolutely. And Can you tell me about a time when you finished your PhD and you went out into the world and kind of what that experience was like for you? You know, you did your master's, you did your degree, you did your master's, and then you've gone on to do a PhD. That's a long time studying. What was that kind of first job like for you?
Yeah. Look, I actually, as I said, I've always liked both sides of academia and practice, such that I'm always studying. Till today, 20. My graduation was 25 years ago, so I've been an engineer 25 years, and I haven't stopped studying. So I have a few degrees under my belt, but I've always tried to work in parallel a little bit. So it wasn't quite when I finished my PhD that I didn't have practical experience. I already had. I had worked before. And that was actually helpful. It does help if you have a little bit of practice, practical understanding, and you go to a research, because you have that, mentality of, how am I going to use this in practice? But I have to say, when I finished my PhD, it was actually in Australia. Was my first job in Australia, and that's where sometimes you're going to experience things that you feel a bit uncomfortable. And I did feel a bit uncomfortable. My first job in a different language. And I felt a bit out of my comfort zone. I had to start doing things that weren't so technical too. So I'm quite technical. But, it's important as engineers, we need to do a lot of different things. We have to be good managers, so we have to project manage things. So I started doing a lot of project management in smaller jobs, and I felt challenged. Particularly in a different language. And getting exposed to a bit of a different environment, but. Again, when I was looking for my first job here in Australia, I again focused on the growth path rather than just salary, right? So I said, I want to work for a company I know will provide me with people who teach me. So I did search for a company with people that were well known in the industry, and I knew it would provide me support and help me grow as an engineer. And, I'm very glad. And I actually turned down better offers at that time to be able to start in that company. And, I'm glad I did, because I learned. And, you might say, David, but, we all need, money to survive. Yeah, but that better offer is only temporary, because, if you grow quicker, if you learn more, you're going to outgrow that salary. You're going to start, develop your career much quicker.
Completely.
And then that's how things started for me here in Australia in terms of the practical side and started working.
Yeah, it's really good advice. I mean, I think it can be really daunting for people when they finish their studies to go out into the real world. You don't have any connections. You don't really know who's who in the zoo, although that would have been a little bit different for you because you were doing your research. So the advice is, when you're starting out, look for the people. Find the people that are going to guide you and hook on and don't let go.
Yeah, we'll support you. We'll be on your side. To say, look, and also be honest. If you feel something, look, I'm finding this difficult. Ask for help, right? Because that's most people be happy to help you and support you if you are in the right environment.
Yeah, that's also really good advice. I mean, I know some people like to hide when they don't understand something. Some people wouldn't speak up because they don't want to look silly or whatever. I fully don't agree with that. I think you've got to ask a million questions so that people and you understand what's going on in your mind. Actually, one thing I was thinking about just now was, do you have any advice for people coming or people that have finished their study and that are out there in the world trying to find mentors? Maybe there aren't any good mentors in their team that they're working in, or What's the Dave approach here? You know?
Yeah, as I said, it can be hard if you're not if you like if you don't know people who can make you recommendations and suggestions and sort of already point you to the right places and path. I experienced this a little bit with other colleagues who migrate from different countries. Actually, or from time to time, I get contacted by engineers who are coming to Australia and said, "Oh, can you give me some advice, some tips?" One of the things I said, in particular, these people, not only they may have, some of them might just have finished their course. Others might be experienced, but also come here knowing nobody. And I say, look, one of the main things is try to get network is important. So try to get yourself in events where you're going to be around people, because you start listening to people and you start listening to names, start listening to names of companies, names of people that will start giving you an idea which one is the best, what path is the best one for you. And in these events, try to talk to people who look in a similar sort of level to you. They may have just started, like if you are a recent graduate, talk to another graduate. So what you feel about your company? Is it good? Do you really recommend work for your company, or do you recommend another one? Do you know another one? Like you start paying, oh, who is a good good mentor in your company, and start asking those questions. Attending events, you might you might see presenters that will present and get you excited, about topics. So we have case in our company of in students who came to me and some other colleagues and said, "Oh, I really love your presentation. Is there an opportunity?" So I feel really happy when this thing happens. And but you can only be exposed to this if you start attending these events. So look for the associations, technical societies that organize these events, and start attending them. You might feel out of place a little bit if you don't know anyone, but once you are there, there's generally a little bit of a 15 minutes, 20 minutes networking with a few drinks. Go at that time, talk to people, ask questions.
I like the idea of try before you buy.
Yeah.
Get some good reviews. It's not as easy to find reviews. I mean, there are reviews on Glassdoor, but they're pretty crap, and there's always bitter ex-employees on there, talking crap. Cool. Okay. So the next thing I wanted to ask you about was, through your research and through the work that you've been doing in industry on major projects, it's really clear that you're kind of pushing the boundaries of where the research is and really pushing the understanding of what is understood on major projects, in terms of geotech, in terms of structures, in terms of civil works. And I was wondering if there was like a specific moment where you were kind of looking at the data and you were like, damn, this is all working. Like it's all coming true. Like this is all, and all the little pieces of the puzzle are fitting into place. I was kind of wanting to ask you about if there any situations like that happened.
Yeah, no, there's something like there's a specific one that I'm very proud of, and it isn't it isn't too old. It's relatively new. But one thing I will start, I am of the view that one of the things I don't like in engineering is the expression said, "I've always done that way," right? I don't agree. I mean, it's a good starting point, because if you've always done that way, it means it has been working so far. It doesn't mean it's the best way. So I've always had in mind of trying to look at things every single time as a new opportunity to improve something, right? So I was working in this major tunnel project, which is here in Sydney, and the way that certain things were designed. A particular element is like in tunnel, particularly tunnels in rock. We support the tunnel with a lot of sprayed concrete, which we also call Shotcrete. And the approach to design the Shotcrete in rock, where we also combine the Shotcrete with what we call rock bolts. So we put these rock bolts onto the rock to help the rock work better. Was always done in a particular way, and with changes in requirements and specifications from clients wanting better products, better quality, the thickness and the amount of material that we had to start spraying, the amount of concrete we had to spray was increasing during that period. And I said, oh Jesus, now we are also in an era where we talk a lot about sustainability. So we are trying to improve quality, but we're also spraying more material, which means it's less sustainable, right? So we're going the opposite. I said, I was thinking to myself, we've got to have a better way of designing these, making more efficient, and in the expression of how we've always done that way was true, and it was working, but it could also mean that it was working too well, and we weren't taking advantage of the full capacity of that element. So I started thinking, is there a way to design this better? And I linked to my rock mechanics view. So you see, I went from a structural topic, and I started thinking from a rock mechanics topic, how things would work in a rock, for example, when you have defects, when it cracks and the rock rotates, and how it gets stresses that distribute within the rock, even when they have fractures. And I think, well, Shotcrete and the sprayed concrete, when they deflects, it will also crack, right? And it's unavoidable. We try to make the cracks too small that nobody notices, but they crack. And so, well, we don't really take into account those cracks when we're designing. So, but how do those cracks behave? And I started linking to this connection with rock, and I said, there's got to be a relationship there. And I started investigating this in the theory behind it, which we could be talking here for at least another couple of hours. So I'll try to make it quicker.
I'm all right with that.
I started linking that behavior and how this in rock we call this voussoir mechanism, like when things you see this in bridges that are made of rock blocks, like how blocks that look to be loose, they are not glued, but they still work because they transfer compression. So I started investigating theoretically, started doing a lot of modeling. So if it cracks, how does it do? And a lot of analytical, numerical modeling, very sophisticated modeling, and I realized, Jesus, this was true. There's a relationship here. There's a similarity to how the stress is distributed here and how this sprayed concrete can behave. That was showing much greater capacity. Was something in the order of 3 to 5 times greater capacity than what we used to do. But then you start talking this in a big project, where the consequences of a failure can be enormous economically and safety, people get concerned, rightly. And they should, and they say, look, we can't just rely on theory. And then we said, I fully agree. Let's do 2 things. First of all, not only are we going to improve the way we analyze it, but we're going to improve the material itself. And we started focusing on improving the material itself, how the concrete, the spray concrete, the components of the spray concrete. And one of them was using a specific type of steel fiber to reinforce the concrete. And the second way, we said, not only are we going to improve the methodology, the material, but we're also going to do validation, this confirming with a practical large-scale field test where we're going to really build exactly what we're going to build in the tunnel in real life, but we're going to test it to failure. So we're going to load it until it fails in a controlled environment. And then we organize these, a lot of stakeholders involved, suppliers, the contractor, the road authority here, the client that owned the tunnel. And we ended up doing this test, and bang, again, one of those proud moments. I said, well, all my predictions were correct. It was 3 to 5 times greater capacity, and we built the confidence because we had the theory behind us. We had the validation through large-scale field tests. We had an improved material, and that actually material became now the new standard. So most shotcrete used in Australia now, particularly in Sydney, now started following that type of mix that we developed in that project. So that moment I was, well, hang on, there's a connection with rock here and how it behaves. I probably can use it. Was my aha moment that created something special.
Oh, that's a really great story.
Yeah.
So, when we're talking about these complex geotechnical models, you're really refining this model in your computers, and you're testing out different properties of rock materials, and you're testing to see what the movements are. Can you maybe walk us through the important steps of really validating that against what's actually happening in real life. Because I think that's a really important step. I just want to know what your thoughts are on really validating the models, because I think that's really important for us and maybe even for young engineers as they're coming through their career, you know?
Yeah, no. So I always keep in mind, and I'm going to try to put them together a little bit, but I always keep in mind a few quotes and expressions that sort of guide my thinking when we're doing this complex analysis. You know, I'll say a few, and not in no particular order, but you know, when they come together, it will help you build a good analysis and good concepts. The first one is there's a quote. I think the name of the philosopher is Kaveth Reed. He says it's better to be approximately right than precisely wrong. Right. So when you're building a model, you don't need to include every single detail to the precision, because you may make it so complex that it will give you a wrong answer you won't notice. So it's better to approximate something that targets the questions you want the answers. Like, you know, so first of all, when you're building a model, you're building a concept, you have to think, what answers do I need from this model? I don't want a model that will tell me, you know, they will try to, explain the world. I want to answer particular questions. So focus on those questions, right? So for example, in a ground model, sometimes we will be doing a model because we want to understand deformations. So we want to predict if, for example, a foundation, we're going to be deforming too much to the point that it will cause a problem to a building. So your focus on that particular model is movements, deformation, settlement focus. So your focus on that model will be at that. Others will be, well, I really want to know if a particular structural element that will be supporting an excavation, for example, will be working. That's it could be the same model, but, in some details may change that will help you to answer better those questions. So, in developing that model is that start simple. Always start very simple. And every single step, you're going to build up a little bit of complexity, you test. Right, so in engineering, we can build very complicated non-linear modeling models, that have non-linear materials, non-linear geometry. I've always started with very simple geometry, linear elastic behavior, right? Because it's very intuitive. Linear elastic, it's linear, so you can actually imagine if I increase the load, deformation will increase linearly. So then I build that model, I test it. Oh, it is the linear model behaving like it is? Okay, now I'm ready to increase to the next step. Okay, and then I introduce a material nonlinearity. Then I can introduce geometrical nonlinearity. Then I can introduce, for example, I can start a model that it doesn't have a structural element first. Then I put the structural element. The other thing is, to every single component, you try to calibrate. So for example, if you're going to model I mentioned rock bolt, for example. Sometimes we try to understand how is the behavior of that structural element in your model outside in a simpler model before you put it inside in a complex model. Because if you understand, in a simpler model, when you put in the complex model, you will know what it is supposed to be doing in that complex model. Because if you put everything together, all you know is that jumbled variables. Up. Exactly. Too many variables. So that's it. And also, the other expression I have in mind, and this doesn't come to any particular person who quoted, but I remember I always treated my models as, I always assume they are wrong. No matter what, I always try to prove they are incorrect. So I look at the results over and over, try to find an error. If I can't, then I try, then I slowly build my confidence in that model. Hang on, no, I think I did the right thing here. I cannot prove it wrong, because if you go the other way, if you treat it, oh no, the results should be correct, you might oversee something and just assume it was correct. But so I always try to prove it wrong. So you're always start testing something at the end, and spend the time at the right amount, right? The analysis itself is generally a small component of your time. So I always say this, like, it's, if you get 100% of time, is generally you have 50% of the time is really building that model. You really need to spend time building it. It's only maybe 25% is actually analyzing it. The other 25% is investigating the results and trying to make sense and show that they are correct or they are not wrong, like I say. So that's my principles in this complexity, sort of modeling.
And what advice have you got for people, that are working on these models? How do you properly document all these little decisions that go into the model? How do you, as a modeler, really help your client or your contractor or whoever's helping or whoever's, established the model? How do you really give them what you've done? How does that bit come to fruition?
Yeah, then is where that's what I said. Like every engineer, we need a large number of different skills. Being able to manage your own inputs and outputs is something you learn with a bit of practice. So if you do the way I said, incrementally, right? So along that path, you can start writing down all the, every time you do an assumption or an input that is changing that model incrementally to increasing the level of complexity, you know exactly where that change is, and you can start, making your notes that will eventually go into a report. So in your report, you really need to structure, what was all the parameters that I've entered. So, for example, the parameters that are associated with material behavior. What are the parameters associated with geometry, right? What are the assumptions behind some of the components of the model? For example, you may have a I call a ground engineering model, for example, that the ground itself might be non-linear, may have a failure, constitutive material that allows the ground to fail, but I might be using structural elements that are elastic. And that's okay. I mean, we do that most of the time, actually, but so you say, look, I assume that my structural elements are elastic. So you put that in your report. Then, of course, because you made that assumption, you're going to have to check the capacity of that structural elements in another way outside. So you get the design action effects from your model, the axial forces, bending moment, shear forces that are developing that structural element from that linear behavior that you have assumed, and you're gonna assess if they are within the capacity envelope of that structural element. But the way to get it structured is if you develop a strategy on how to build your model, you're gonna know exactly the steps that you have taken and each input that you have assumed. So that you can convert that input into a report. And it is important, as you say, to write down every single assumption because, unfortunately, still things go wrong. And if it does go wrong, you need to give an opportunity for someone to investigate that model, that analysis, to see if there was something wrong. And if there was, that we can find. And we can also keep this in mind. When you're writing something, try to write in a way that think of someone else trying to recreate the same model. So you need to provide enough opportunity that, if another colleague of yours or, someone else is going to rebuild a model, and you need to understand every step that you have taken so he can rebuild your same model. Because if he builds differently and gets a different result, then it's also partly your fault because, you haven't provided enough information, right? And you're going to be arguing, okay, no, mine is correct. Okay, but hang on. Why? What did you assume that's different than mine,
Yeah, completely.
Yeah.
So document every property, document every change.
Assumptions.
Keep it simple and then develop complexity.
Yes.
Okay, I'm going to flip it now, right? And I know you've done a lot of work. You might have been reviewing colleagues' models and you might have been looking at things in the past. If you were a client or if you're someone who is, having a model created for them, where would you say the most important places to look are to find problems or to find, areas where there could be issues?
Look, like the first place is really the reporting, right? Like if you look at the report, and you're gonna get a feel for if it has been well documented or not as you read. Then then it will vary a bit depending on type of modeling, and but as I said, it depends on what sort of input you have on your hand. If you have the model itself, you can start to open the model. If it's a particular software, you can open that model and start investigating the inputs. But of course, besides the reporting, then the next one is the outputs, right? Pictures. Like when you're doing complex modeling, we all love to do our beautiful pictures, very colorful pictures. A lot of the times you can see if they make sense or not by just looking at the pictures. Okay, these results don't make sense, and you can I have a number of times where I just looked at the contours and said, look, no, these contours, they don't look right, and when we go to the model, we find a mistake. I always start at the basics too. Even if I'm investigating, say models have a few very basic things that are often overlooked. Boundary conditions, for example, how far boundary conditions are from your area that you're investigating. So in a ground engineering model, boundary condition needs to be at a certain distance, because if they are too close to the problem, they will hide the behavior, the right behavior. For example, just imagine here, I'll give you a very simple example. If you're modeling an excavation, say from the surface, say a basement excavation, and then you put your boundary of your model too close to the excavation, your model doesn't have enough material to allow it to deform, because the boundaries are generally something fixed, which will stop movement, right? And it will be affecting your final result. So, looking at the pictures of a model, I can say, oh, hang on, this boundary here is not correct. So, it does require a little bit of experience, to be reviewed. I would say it requires, of course, more experience to review someone else's work than to do your own, right? So I would say, first get your experience doing your own modeling, and you're gonna make mistakes. That's fine. Learn from your mistakes, because then your mistakes might guide you to find the other people's mistakes, right? Because
I think we've all been there. We understand the details in some particular, minute area, and then every time you review things, you go straight to that.
Yeah, exactly. Yeah. So I've done that before. So
that's good advice. So, looking at the report, checking all the variables, really diving in, and if possible, start playing around in models and trying to learn from doing. I think that's good. Okay, so I wanted to ask you now about maybe an experience that you've got where things didn't go to plan, And I know that this happens a lot in people's careers, and it's probably something that we don't all talk about very much. Do you have a project or an example of something where you're kind of thinking to yourself, oh, this is a sure bet, and then maybe things didn't go to plan?
I do. Luckily it wasn't. It wasn't anything serious. But because of the approach we've taken, sometimes, as I said, we're always looking to improve things, to make things work more efficiently, that's the only way we can develop and improve. Like we were challenging a bit the status quo, but sometimes we'll make the wrong bet, right? But as long as you make the wrong bet in a way that you know what the consequences are, and that you it's controlled, and if it doesn't work, you have a plan B. That's the right way to do. So I have an example on a real project where we wanted to increase the limits of how certain, and I mentioned the word before, rock boats were operating. So we use, as I said, we use a lot of rock boats to support tunnels. These rock boats, they have to last, many years, 100 years to be more precise, or more. And then these rock boats, they have a certain corrosion protection, which involves, for these 100-year design rock boats, they have this plastic sheath, this HDPE plastic sheath, Unfortunately, the rock bolt is made of steel, can take a lot of deformation before I have a problem, but the plastic itself, depending on how it's deformed, it can tear and puncture. So they have a limit on how much deformation they can have, particularly in shear. And we have started work in Sydney here with a particular number in mind, which I don't need to say so specific, but like what was a number, and we thought, oh, hang on, maybe if we use this different configuration of the plastic sheath here, we can increase that limit, and gives us more room to work with the rock bolts before. Because what happens is once these limits are exceeded, what we have to do, we have to install more, right? Because if they exceed it, means there's a risk that durability of that element is affected, and then we just install more.
Not going to last the full 100 years.
Exactly, but so that is the consequence at the moment, right? So we thought, so let's change the configuration of this plastic sheath, and we started doing some tests. And we got really excited. It was, Jesus, it is seems to be working. Then, as I said, we work in a group, and, there's always reviewers. And, one of the reviewers made the right comment and say, look, but hang on. Can we investigate what happens if these rock bolts, they have grout inside them? Can you investigate what happens with the rock bolt with the grout, if the grout has this particular strength? When we were testing for the value we specify as a minimum strength. We said, look, we want the grout to have this minimum strength, and we are testing at this value. I said, but hang on, the grout sometimes might be a lot stronger. And we said that's true. Okay, that's fine. We're happy to test it.
It'll be more brittle.
Brittle, and that was exactly the problem. Because it was more brittle. The deformation was a lot more localized, and when we are testing again, it was again showing that this plastic sheath was we thought was better, was tearing more or less at the same amount of deformation, and we saw, which means that we couldn't improve. So we spent some effort, trying to develop. As I said, the consequence at that point wasn't anything big, because while we were trying to prove this, we were still working with the old limit. So we didn't have to change anything. So it was the right decision to be made. But in the end, it was a real project, so we couldn't be doing 2-3 years research on it. And we said, okay, now hang on, we have to be practical here. So let's proceed with the old limits, and let's keep this in mind for the next projects. We haven't given up yet, so we just gonna revisit this in the next project, because we that's the only way we can develop. We know what to fix now. We know I said particular strength we specify a minimum. It might be the case that we need to specify a maximum as well and operate within that range, right? So there's opportunity for us to be improving, right? So we didn't have in this particular project, because we started the project without specifying that maximum, and but in the next one I might have the opportunity to, right?
What an interesting dynamic, potentially spanning the research that you're doing across multiple projects. I know also, when you're working in these major projects, you don't just have one sole hat on. You might be doing geotechnical calculations. You might be looking at structural calculations too. Can you tell us a little bit about kind of your philosophy on, do you really, is it good to really become specialized and dig really deep into one aspect, dive into modeling or dive into construction, or kind of, what's your thoughts on that? And I know that you do wear multiple hats, which is a bit of a tell, but what is your thoughts on that?
Yeah, look, I do think it is good for you to have a special passion on something that you try to become the best at that topic, right? But without limiting yourself to only that topic. So as you said, there's a bit of a tell. I think we do need to know a little bit of multiple things for several reasons. One, remember when I was talking about my aha moment, I was using a concept from one area onto another. So that is where you're gonna shy. Because if you're really specialist in this, but you have a good knowledge of others, then you're gonna start improving the area that you're already good at by using different ways of looking at the problem at that area. So I use a rock mechanics view to improve a structural design view. The other thing is also not depending, but like things are a bit seasonal, right? For example, I've worked in mining business before, and mining sometimes has these booms that really go, hot, and there's a lot of work in mining, and then it goes down, then it goes again, and tunnels are the same. I do a lot of work in tunnels. My current role is a director in the tunneling area. Tunneling also, you don't have one tunnel, happening every year in the same city, So by having a good understanding of other topics, you make yourself more versatile to be working in other areas as well. So if you do ground engineering that's focused on tunneling, but you have good understanding of ground engineering, you're going to be able to use that ground engineering for a foundation design, for a bridge, for a building, or for an excavation, right? So having a little bit of understanding, and I do recommend, particularly when you're starting a career, to venture through these different topics a little bit, even if later you start focusing on one more. But yeah, don't put yourself in a particular shoe box, because that might come and bite you. And yeah, if, for example, if there's not enough work in tunneling and you can't do anything else, what's the company gonna do with you? They're gonna say, "Oh, I'm sorry, I can't give you work. All you can do is tunnels, right? I don't have any tunnels." So don't limit yourself. Absolutely. Take the best of multiple subjects, because it can also help the one you are specialized in, right?
Yeah, I think, everyone that's worked in tunnels in Sydney at the moment's really feeling that, the work from the transport is really drying up, and everyone's having to reskill and get more incorporated into other types of projects. Where do you see all these the experience and expertise moving into over the next few years?
Yeah, tunneling is an interesting one too, because there's a lot of similarities with, for example, I mentioned mining, right? So there's an opportunity that you might put to good use the same knowledge from tunneling in mining, and it did the other way as well. A lot of when there was the boom in tunneling here in New South Wales, not only in New South Wales but in Victoria as well, there's still a lot of construction. There was a lot of people from mining who were coming across, because it's transferable. A lot of the knowledge some of the regulations will be different, but you cannot just, because it's similar. There's a lot of similarities. You can adjust more quickly. So there's an opportunity there for tunneling. But look, infrastructure is something there always going to be a need, right? And we all keeping our eyes open for the next big hub of infrastructure, which here in Australia seems to be very soon Brisbane because of the Olympics, but there's all the other areas too. There's always need for housing, like, property development and things like that. So I think we just, as I said, if you are versatile enough, you're going to be able to be working in these infrastructure projects. For me, I'm an example of this one. I'm still involved in a few tunneling projects, but in parallel, I'm helping our teams in New Zealand on a tender for a highway, where I'm helping with bridge design, right? Just keep an eye, and keep that. If you're versatile and focus on putting your hand up, say, look, I think I can provide you some contribution here using my knowledge from this industry here, because some of the components here are transferable. I understand how ground structure interacts, and so I can help you with your foundation design, of your support design for your excavation and things like that. So that's what we have to do. But civil engineering in general will always be work, and and then when you combine this with mining engineering too, there's always opportunities out there.
Yeah. How many years have you been in Brisbane now?
4 years now, completing 4 years.
So you're pretty well established and ready to make the most of the Brizzy Olympics boom.
That's what we're hoping for. Yes.
I know a few engineers that have just moved up there, actually. more affordable housing, great projects to work on by the beach. And then here we are in Sydney, you know, it's been raining all week, and all the projects are drying up.
Yes. Well, look, it was raining in Brisbane too the last few days. So
I also just wanted to ask you, you know, like we're all getting pretty excited about the future and where things are going with research, with construction, with theory, you know. I'm wondering what you think people are going to be researching in 10 years, and, you know, maybe follow-up question will be, you know, what are the things we're doing to stay on top of where the industry is going as a whole?
yeah, look, I mean, research is, if you look at, you know, I'm always looking at, you know, technical papers, journals, and anything like that. You know, there's a huge variety of topics, so it's hard to really predict. But you know, we know that the hot topic at the moment is you know, artificial intelligence, right? There's a lot of things going on. Everything we are on our, you know, day-to-day lives, we're seeing the use of artificial intelligence more and more. One of the things that I see, because of course that has a huge impact on productivity and safety, is the use of that artificial intelligence combined with, you know, autonomous equipment, you know, excavation equipment and autonomous surveys. I mean, mining, there's a lot of, you know, it's a lot more common to have autonomous, you know, equipments where people are operating these equipments from, you know, kilometers away, kilometers away, operating, you know, machinery that, you know, go underground. The reality is that, you know, it can improve productivity and also improve safety, because people, putting people, particularly in a mining where, you know, sometimes they do have you know, a different sort of risk level. In the tunneling industry, for example, we are starting to see autonomous tunnel boring machines, for example. So there's a lot of you know, investigation in how combine that with artificial intelligence. For example, in a tunnel boring machine, the tunnel boring machine, when it's operating, there's a number of variables that are being fed, you know, being analyzed as part of the operation to see if it's, you know, the progress, the advance is okay, if the stability of the excavation is okay, you know. There's, you know, quantity, for example, depending on the type of machine we're using. For example, we have internal boring machine, we have a few different types. We have, you know, one that's very commonly used, it's the earth pressure balance machine, which uses a screw conveyor, and that screw conveyor takes the amount of soil, so you're always assessing how much soil is coming out, and that's is an input to, you know, to how the machine is operating. The face pressure, so there's sensors that measure face pressure. There's always been, you know, in you know, artificial intelligence also, of course, gives us this opportunity to analyze this large amount of data in a much quicker. So you know, we're seeing this more and more. How to also build things more efficiently. I was actually, I do like, I would say the professional side of the social media. You know, for example, I do love my LinkedIn because we see some amazing stuff there. And I know this I think it was only yesterday I was looking at this post, and this guy was showing this video of software for structural engineering, where he got a piece of paper, he drew a model with pencil, right? Of course, you have to provide some of the right input, but he drew in 2 minutes with a pencil. He marked up dimensions, took a photo, and that software converted his drawing onto a working model, right? And then he analyzed it.
What?
You know, like, so you know, like these sort of things, you know, expediting, you know, how you build models that, you know, sometimes can be boring in something that's really quick. There's one that I know in ground engineering, where I you know, I saw it, you know, in a demonstration. The developer showing to me, he was just giving voice guidance. So please do that, you know, build this way, assume this, and you know, the models are creating. So so there's a lot of opportunity in that space, and you know, for the, you know, younger generation that are keen to do some programming and, you know, like their computer, there's a lot of opportunity to be working in that front and making things quicker, you know, faster. But as long as we understand the basics, we can't forget that.
Yeah. So that's kind of good as an overview. I wanted to ask you specifically, what kind of stuff, you mentioned AI, what kind of stuff's Dave doing right now to keep on top of AI?
I particularly, like myself, I am not actually, to be honest. I use very little. I probably should be doing more.
Don't worry, we all feel like that. Don't worry.
Yeah, I don't know. It feels daunting, doesn't it? Like, a little bit. But no, I am not specifically looking at AI. What I have been working with, a lot of the engineers who work with me, is more on it's not quite artificial intelligence, but a lot of scripting, how to make things more efficient. How to...
I mean, that's using AI to your advantage. You can't say you're not doing it. It sounds like that's exactly what you're doing.
Yeah, well, no, in a way, as I said, AI is so efficient that even when it's writing a script, like, for example, you use Python, right? Like everybody now is learning Python.
Yeah.
I tell you everybody learning Python because, my son, he's only 15 years old. He's learning Python at school. He's showing me how to program. I said, Jesus, I can't do that. So then you can use AI to create the base of your Python. So you can go to ChatGPT and say, can you write me a Python script that will do this? If you provide the right input, it will give you the script, right? So that we are doing. I am doing, so from time to time we, use AI for that.
So hang on. So your 15-year-old is inspiring you to use Python to do stuff at work?
Oh, no, yeah. Well, yes. I can see, I said, I used Python like 13 years ago, right? And I stopped. Then I seen this coming back up, and particularly my son, he's doing gaming in school, like programming, gaming. And I said, oh, he's really excited, and it got me excited too. So if he's excited, it got me excited again. But and that it gives us a lot of opportunity to extract, because sometimes we talked a lot about complex models, right? And complex models generate a large amount of data. Sometimes we don't even look because there's so much data.
Yeah.
Then you can use this machine learning and scripting and to extract these and start generating plots and inside that you can then look at the results in a easier way, because as I said, it's complex. When it's complex, there's too much data that gets unused.
Yeah, crazy. I really find that interesting, because even at my work, there's one guy particularly, I won't say his name, he started doing things in Python, and then I saw what he was doing and I was like, hang on, this is what I should be doing. And now I've been using, AI to generate Python scripts to build reports and photo reports and resize all the photos, and it probably saves me a full day's work, Yeah.
And even as I said, I've always liked the academic side. I love teaching, right? I have this in mind that the best way of learning is trying to teach. You have to think differently. So I love teaching because every single time I teach, I learn, right? Because I try to explain differently. I try to explain better. And what the other thing I'm using AI too is helping create really good, cool pictures, right? Like these days, you can before you need hire a graphic designer, expensive, and now these days, sometimes I'm worried about graphic designers, and I tell this because my wife is a graphic designer, so Jesus, they have tough competition, but that's where they need to understand and be flexible. They will have a next level, so they will use the AI for those things even better than you, right? So so as long as you are with the flow and you don't get left behind. So.
And do you, we're coming to the end of the episode now. I'm wondering if you have any advice for, people who might be looking at your career and thinking, wow, that's a really cool, Dave's got a really good, understanding of the theory, and we know based on your experience that you're really a gun when it comes to practice too. What advice do you have for people who, might be wanting to do the same things as you, and maybe, to finish kind of the episode on?
Yeah, look, it's as I said, I can't not hide that there's always a little bit of luck, right? But do not settle for the mediocre, right? Try to find the thing that really sparks your curiosity, because if you're curious and and you start then creating the enthusiasm, and the enthusiasm will generate passion, and with those three components, curiosity, enthusiasm, and passion, there's no doubt you're going to deliver quality work. Once you deliver quality work, it just gets exponential, right? Because you're delivering something quality, because you're going to inspire other people. People are going to see you, and then you're going to start building that circle of high quality teams, and that will deliver great work with you. Keep in mind what you're really providing at the end of the day with your work. And as I said right at the beginning, I look around and say, look, I am contributing to society here. I can, people will be riding this train here because I helped build this tunnel that where this train is going through. Oh, this motorway that goes through this tunnel is also something I was involved. Oh, this building here, I helped the foundation. Keep that in mind and take pride on that. And sell it. Even if your wife is bored at you all the time, and say, but look at this, it's really cool. It was really challenging. But you have to find the thing that will really bring that curiosity, sparkling. So do not settle for mediocre. If you're not happy with something, try the next one, right? Of course, there will be challenges. Like sometimes we'll need to stay at certain places, but keep the opportunity, also the doors open, the windows open, and then jump onto them. And get uncomfortable, like if you need to.
Get uncomfortable. And as you said at the start, sometimes the thing that's going to completely spark, sometimes it doesn't start with a spark.
Yep.
And sometimes all it is one conversation with someone that really switches you on and really gets you thinking about stuff that can really inspire you to keep going hard. So, Dave, it's been really good having you on this episode. We talked through your experience in research. We talked through some of your advice for young engineers. And we really dive into some of the theory behind some of these really complex models, which I'm sure people are going to really love online. I really appreciate you coming in to speak to me today. I've got you a little gift.
Oh, thank you.
Which is your very own Full Send Engineering shirt, as I've given all the guests that have come onto the show today. So, look, I really appreciate you coming in. I know it's pretty far out of your way from Brisbane, all the way down here in Sydney. But thanks for coming on, Dave.
It was a pleasure.
Yeah. And look, if you're online and you like the sound of the things that we're talking about here today, please like, comment and subscribe. All that we're really trying to do is really to share the stories that are behind the engineers that are pushing the industry forward. And I think today's been a perfect example of that. So thanks again, Dave. That's been a really great chat.
Thank you very much.